This is a May, June 2022, 41 variant question 1. A part 1, state Newton's law of gravitation. To answer this question, we need to know what is Newton's law of gravitation. We assume that there are two masses, m, and the other one is small m, separated by distance of r. Newton's law of gravitation states that the gravitational force is directly proportional to the product of the masses and is inversely proportional to the square of their separation. So these two equations, when you combine together, you get F directly proportional to product of the masses divided by the square of their separation. Inversely proportional to the square of the separation. When you replace the proportionality sign with an equal sign, then you will get F equals to G, which is a constant, m over r squared. So this is a formula to calculate the gravitational force between two objects with masses of m, big M and small m. So to answer this question, which carry 2 marks, we have to say that the gravitational force is directly proportional to the product of the masses. And to get the second mark, we must say, and is inversely proportional to the square of their separation. In part 2, use Newton's law of gravitation to show that the gravitational field strength, G, at a distance r away from a point mass, m, is given by this formula. So to answer this question, we need to know two things. We need to know the symbol for gravitational field strength, which is your small g, and we need to know the definition for gravitational field strength. To score the 2 marks for this question, the first mark is the gravitational field strength is the gravitational force per unit mass. So G equals to gravitational force F divided by mass. Then the second mark is your F is equals to G m over r squared as proven here. Therefore, your G is equals to the gravitational force divided by m. When you can cancel off the small m, you will get Gm over r squared, which is proven. That's why I get the 2 marks. Then in part B, the Earth has a mass of 5.98 times 10^24 kg and the radius of 6.37 times 10^6 meter. The Moon has a mass of 7.35 times 10^22 kg and the radius of 1.74 times 10^6 meter. The Earth and the Moon can both be considered as point masses at their centers. Their centers are at a distance of 3.84 times 10^8 meter apart. In part 1, show that the gravitational field strength at the surface of the Moon due to the mass of the Moon is 1.62 Newton per kilogram. Since we want to find the gravitational field strength at the surface of the Moon, we need to know the radius of the Moon, which is 1.74 times 10^6 meter. We use this equation here to calculate the gravitational field strength. So G equals to big G over times m divided by r squared. Then you substitute the values inside, you get 1.62 times 1.62 Newton per kilogram. Then in part 2, explain why there's a point X on the line between the centers of the Earth and the Moon, where the resultant gravitational field strength due to the Earth and the Moon is 0. To answer this question, we need to know that gravitational field strength is a vector quantity. It has both magnitude as well as direction. So let's say this is the Earth and this is the Moon. And the centers are separated by distance of 3.84 times 10^8 meter. And let's say this is a point X. At the point X, the gravitational field strength due to the Earth is acting to the left, represented by GE. And the gravitational field strength caused by the Moon acts towards the right, represented by GM. At this point X here, the GE equals to GM. As you can see, the two arrows are of the same length, but they are pointing in opposite direction. So to score the 2 marks here, you have to say that the gravitational field strength due to the Earth and the Moon are equal in magnitude, but opposite direction to get the second mark. In part 3, we have to calculate the distance x of point X from the center of the Moon. This is the diagram to represent the situation discussed earlier. X is a point between the Earth and the moon. X is further from Earth and nearer to the moon because the mass of the Earth is much bigger than the mass of the moon. Let the distance of X from the moon be X meter. So this distance is X meter. So the distance of X from Earth will be equals to 3.84 times 10⁸ minus X. So this is the distance of X from the Earth. At this point X here, the gravitational field strength due to the Earth is equal to the gravitational field strength due to the moon. So equate the gravitational field strength of the Earth equals to the gravitational field strength of the moon. Then you can get the answer X equals to 3.8 times 10⁻⁷ meter after solving the equations. These are the data which are provided earlier. In order to answer this question, we need to summarize the facts that you need to know to solve this question. First, you must know Newton's law of gravitation. Then you must be able to define gravitational field strength. Then you must know that the symbol for gravitational field strength is G. And gravitational field strength is a vector quantity. It has both magnitude as well as direction. As a result, there is a point between two planets where the resultant gravitational field strength is 0.